Okay, well, thanks everyone. And I'm Laura Cunningham, California Director at Western Watersheds Project. And I'll introduce each panelist when they're going to speak. But so to dive into this is a panel on tips for looking at misinformation that you might find in range management, different perspectives to give you an idea. And I'll start with a presentation that's California specific. I have a background studying the ecological history of California grasslands, which I've been doing for decades now. And so this is a shifting baseline type of presentation. So let me see if I can. Okay, you know the famous Aldo Leopold quote? I mean, I have to keep reminding myself of this over and over. I'm gonna go quickly through this because I have way too many slides. But yeah, intensive livestock grazing in California has resulted in pretty much a shift in loss of 99% of our native perennial bunch grasses, and it's basically most cattle pastures are quite weighty Mediterranean annuals, Eurasian annuals. So this is what we see now on the ground, and people just think this is normal. Here's a picture of a bunch grassland, foothill needlegrass, one of the stipas that you see, and I've been trying to study these, find these across the landscape in California and record these. I mean, you can find some just beautiful relict and what I call reference sites for native grasslands, full of biological soil crusts. They can be really amazing. Here's Point Reyes National Seashore, has a couple of undisturbed elk grazed coastal prairies. And you can see here, this is an Idaho fescue coastal prairie bunch, which is just so different from the usual cow pasture full of annual grasses. But the annual grass pasture in California has come to be thought of as normal. Here's just another comparison of elk grazed coastal prairie and the usual cow pasture with annual grasses and bare ground. So many land management programs rely on monitoring of vegetation and rangeland health to guide future management decisions, yet current methodologies often fail to capture the full richness and structure of potential baseline plant community types that could be used as reference sites. Again, another comparison of a spring with I try to get pictures of all these in measurements to see how different they are, grazed and ungrazed. So I happened upon sort of the history of vegetation analysis and monitoring. Frederick Clements, 1874 to 1945, was one of the early pioneers in vegetation science. And he became very interesting to me because he developed something he called the relict method, where he even back in the late 1800s, early 1900s, he was seeing the big native grasslands, the herds of bison and elk disappear with colonial settler emergence across the land. And so he was developing ways to find these relict grasslands and record them. And it's interesting because historic artifact was kind of a big part in this type of method, because he found in the San Joaquin Valley, Central Valley of California, hundreds of miles of purple needlegrass, cool season native bunch grasses. And I'm like taken aback reading this because this is all farmland now. It's all completely gone, type converted to agriculture. So he recorded a lot of things that were just wiped out. And he also started studying fenced exclosures early on, like in the teens, 1900s. So that was he discovered that fenced exclosures can be a really useful tool. So it's sort of an interesting history of all of this. Here's Edith and Frederick Clements, and I bet Edith doesn't get enough credit for all of this, but. So he developed something called successional vegetation, where you have, pioneer to climax, and this is sort of the classic vegetation science. And here's an old range management textbook page, but I just love this diagram showing, the pioneer stage of bare ground, and then different annuals colonizing the bare ground, and then the climax is the perennial, long-lived, deep-rooted native bunch grasses. And the interesting thing about this is very interesting and tells a lot, and you can go out in the field, and this actually is very helpful to look at this kind of old chart, but current range management is trying to hide this stuff. They sort of don't want you to understand this type of ecology because you might see how degraded most pastures are. So fast forward to the 20th century, 21st century, and we have a replacement for that clement type of vegetation ecology called state and transition models, which, you delve into this, and I think there's a lot of good in state and transition models, and I think it's worthy of, studying. Although again, it's trying to sort of hide some of that classic range management, which can be really interesting to also study. So interpreting indicators of rangeland health is one of the good models that some range managers are using. Describing indicators of rangeland health is a simplified version. I think these are really good. They talk about reference states, the potential natural plant community, and importantly, they reference that this is described as a historical state within a 500-year period preceding European settlement. So I like how they have like a time period. We're not talking about 7,000 years ago, but something that's reasonably that you could probably, recreate if you're restoring a grassland. So, like I said, though, there's a trend in ecology away from climax theory of vegetation progression promoted by Clements towards the steady state models, which are really useful. I think they say, there's reversibility of climate states. They have a lot of, new modern theories. But again, you can use these transition models to sort of hide how degraded a pasture is. And I think that's becoming more of a problem. Ecological site descriptions, I'm going to skip doing some of this because I want to go fast. Ecological site descriptions are really good. They involve doing soil pits, which the method I'm trying to do for California does not. It's based on this, but a lot of times I can't get a permit on public lands or parklands to dig a soil pit. So I actually have to develop like a triage model to go and find and measure relict grasslands and the degraded pastures. But I think ecological site descriptions is a really good base to work from. It's very detailed. It has some problems, but it's based on soil types like this map shows, and then each vegetation and climate will give you a specific vegetation association. An AIM, assessment, inventory, and monitoring, is becoming very widely used with Bureau of Land Management now, and it's got some problems. I think it has some good to it, but one of the big problems I've seen is, they basically go out there and they throw out a randomized plot somewhere, and I've noticed that will then completely miss the type of native grassland relict, which sometimes are a square meter. And so these get missed, and so they miss a baseline reference site. And I think this is becoming more of a problem. So we have shifting baseline syndrome happening. Sylvester et al. 2017 defined this as a lack of knowledge about true natural conditions is leading to a shifting baseline syndrome with perceptions of what is natural becoming biased towards anthropogenically affected ecosystems. So again, I'm trying to develop a rapid assessment, what's called a releve method, which is a common method in California at least for quickly inventorying a plot of vegetation, including grassland. And you don't have to look at this in detail, but California Department of Fish and Wildlife and California Native Plant Society have developed a really helpful, quick inventory survey field form to try to just capture like the species, slope, other types of parameters. And I'm trying to develop this for using it for reference sites such as this. This is a little tiny north slope of a hill with prairie June grass, which is just a beautiful native California bunch grass that disappears with heavy livestock grazing. And it may be, just the size of half of this room. And so it's missed by a lot of survey methods. So what I'm proposing in my study is using expert opinion, expert knowledge to go actually just find these reference sites, no randomized sampling, and then describe them with these methods. And we can do soil sampling later when you get a permit. But relic sites, Clements developed quite a nice list of places where you could go look and see things that have not been grazed out by cattle or sheep, just fenced roadsides, highway right-of-way, steep slopes, pasture corners, things like that. So here's a quick succession of photos in California of places where I've found sometimes even just a couple of native bunch grasses. And then for square miles around, it's Eurasian Mediterranean annual grasses with cows. So these are the places that cows just can't get to. And you can use them as reference sites, I argue. Just, hill slopes, empty lots next to houses. This is a regional park with a nature area that doesn't allow grazing. And this whole sward of green is a rhizomatous red fescue, just a beautiful stand. Like a fence line with creeping wild rye, a reservoir edge that they don't allow cattle on, beautiful bunch grass stand, steep rocky slopes with shrubs, the cattle just can't climb up there. And, I'll go through these. This was just one, like a Melica californica, California onion grass, just a couple of plants in a rocky outcrop in a grazed park. A lot of parks in California allow grazing. And to me, this is worthy of studying. Places with cactus that hide the bunch grasses. And mesa tops, this is actually east of Death Valley National Park. Beautiful stand of sandberg bluegrass and a very dry, arid area, and the cows just can't reach it. So my conclusion: to conserve existing native grassland community relics and restore wider areas of these native plant communities, we need to better understand baseline conditions. And so my talk here is just a quick introduction to, what I would like to see as a restoration in California to these deep-rooted native bunch grasses with no bare ground. You have this spongy soil type filled with biological soil crust. So that's my goal. And, I'm grateful for Western Watersheds Project to allow me to go towards this goal. So that's it for me. Thank you.